Hello, my name is Maxwell Johnson, and today I'm going to be presenting on incomplete dominance versus codominance. So, starting off with incomplete dominance. So, this is going to occur when there's two different alleles of the same gene, and uh, basically, those two different alleles, both coming from different homozygotes, combine to form a heterozygote, where instead of displaying the dominant trait, it displays both traits at the same time in an intermediate form. Intermediate meaning between. So, for example, with basic colors, the intermediate between black and white would be gray. So that's what intermediate means in this case, not advanced level or anything like that. It just means in between. So with snapdragons, snapdragons are a really good example for this. You have a red homozygote and a white homozygote, and if you cross the two, you form a heterozygote with the intermediate color pink. So, in a typical case, if you cross the big R red homozygote with a little r white homozygote, it'll always come out as red. But that's only in the case of, regular dominance, not incomplete dominance. So in this case, it ends up being pink. So, moving on to codominance, this occurs when two different alleles are expressed at the same time. So, a really good example, I have two examples for this one. A really good example is with camellias. So, I'm going to use the two colors that I used before. You have a red camellia and a white camellia. But in this case, when you combine the two, instead of incomplete dominance occurring where you form a pink color, instead both the red and the white color are displayed at the same time. So you end up with kind of a pattern of red and white instead of just pink. So both traits are expressed at the same time instead of them coming together to form a new trait. Another really good example is with blood typage. So in humans, we have A type, B type, AB, O, all the negatives, all that. I'm just going to focus in on A, B, and AB. So if you have A type blood, you have the A sugar. If you have B type blood, you have the B sugar. And those with A B type blood have both types of sugar. So if we're looking at incomplete dominance, if you had AB blood, you'd have a completely different type of sugar. Whereas with codominance, AB blood just means you literally have some A sugar and some B sugar. So they're both there. It's not making anything new. They're just both there. And then here are my sources cited. So I use the Gen 3020 slides and this article about Mendelian versus non-Mendelian inheritance. Thank you.